In this video, we are going to learn the concept of attachment. Attachment is something that, or if is a feature of the ProModel that can help us to capture scenarios where we are processing different entities at the same location together. This feature can help us to model assembly lines. For example, in assembly lines, it happens a lot that on a specific machine, we have part A and part B, and we assemble them together, or we process them together, and then they come out as a new entity, as a different entity. So that's the scenario where attachment feature of ProModel can help us to capture that model, where different entities come together at the same location, they get processed together, and then they leave the system. And this is different from the batching that we learned. In batching, we process similar entities at the same locations. For example, we have an oven, and in that oven, we process 5 similar parts at the same time. So that's what we perform using the batching feature. However, for attachment, as I mentioned, is the scenario when different entities come together. And similar to the batching, for the attachment also we have temporary attachment and permanent attachment. Permanent attachment is the scenario where different entities come together and they stay together for the rest of the process. For example, I may have an entity, for example, TVs, and then my other entity is a box. Then at one of the operations that we are modeling, I put one TV in a box. So these are 2 different entities, and in the packaging operation, I put the TV in a box, and then for the rest of the process, this would be a box TV that is going through the rest of the process. So these 2 different entities come together, they get processed together at one location, and they stay together for the rest of the process as box TV, and that's permanent that's permanent attachment. And however, temporary attachment is the scenario where 2 different entities come together and they stay together for some part of the process, but at some point we separate them, and each one of them go through its own path separately. For example, we may have a box as one of our entities, and then we may have a pallet as well, and then we put a box on top of a pallet, and then they go through the rest of the process together. But then when they go through the shipping department, we may remove the box from the pallet and send the pallet back to bring another part, and then send the part to send the part that is ready to be shipped to exit the system. So that's the scenario where 2 different entities come together and they stay together for part of the process, but at some point we have to separate them again, and each one of them goes through its own path separately. That's temporary attachment. So we are going to start by going through one example in which we are going to learn permanent attachment. And this is the example that we want to go to. So first of all, I want you guys to please create a folder for week 5, and we want to create a new model in the folder for week 5. We are going to name this model as shipping boxes - permanent attachment. So permanent attachment is because we are going to learn permanent attachment in this model. Okay. What is the structure of this model? We have a monitor queue in which where monitors come to the system, they come to this queue. We also have another queue for boxes. So these are empty boxes that come to this queue. And then the empty boxes go through the packing, and the monitor also go through the packing. So here is I identified the name of the entity. So empty boxes is the other entity that comes to the box queue. And then from box queue, they go to the packing table. Also monitors from they go to the packing table as well. In the packing table, we put one monitor inside one empty box, and what is going to come out is full box. I did not specify it here, but what is coming out of the packing table is a full box. Then the full box goes to the inspect queue, and then to the inspector, and then to the shipping queue, and then to the shipping, and then leaves the system. The packing operation takes about 5 minutes, normal distribution with the standard deviation of 1 minute. Inspection operation takes about 4 minutes, normally distributed with standard deviation of 2 minutes. And the shipping operation takes 5 minutes on average, uniformly distributed with half weight of 1. We assume that all the parts pass the inspection and go through the shipping queue. So so everything that goes through the inspector passes the inspection and goes through the shipping queue. So we want to learn how we can capture or we can model this system. Can you tell me which part of this operation reminds you of a possible attachment in the system?
The packing table.
The packing table, where a monitor comes in and a box and an empty box comes in, and then we put one monitor, which is one entity, into another monitor, which is empty box. So two different entities get processed in this operation together, and then they leave the system as a full box. Okay. And can you tell me if this attachment is permanent or temporary?
Permanent.
Permanent.
Because?
They don't get separated afterwards.
Exactly. These two items, they don't get separated. They go through the rest of the process as full box, and then full box is the entity that is shipping out finally. Two different entities come together at one operation. They are processed together, and then they leave together, and they go through the rest of the system together. This is a very clear example of a permanent attachment. Okay, so we want to model this. What I want you guys to do, please create a file, create these 7 locations that we have here. For all the queues, put capacity of infinity. For all other locations, put capacity of 1. We talk about it later.
For our lengths of the queue, we're making them 20?
Yeah, keep it as 20 just for the sake of simplicity of our results. Make sure your queues are queue and not a conveyor.
Okay.
Entities monitor is 1. Empty box is another 1. And then the full box, which is coming out of the packing table, is another 1. I forgot to specify that on the graph figure. And both monitor and empty boxes come to the system with inter-arrival times of 15 minutes, exponentially distributed. It just happens that in this example, their inter-arrival times are the same, but it is not a necessary condition. I mean, they can have different inter-arrival times. When we go to the packing table, if one of them is there and the other one is not there, we have to wait till the next item arrives as well. It just happens that here they have similar inter-arrival times, but it should not be the case necessarily. Okay. Please create the locations, create the entities, the 3 entities, create the arrivals. How many arrivals I have here?
2.
2.
For monitors and empty boxes. And then we do the processes together. So these are my locations. Monitor queue, box queue, packing table, inspect queue, inspector, shipping queue, shipping. All the queues have capacity of infinity. Other locations have capacity of 1. I have only 1 of any one of these locations. And for all the queues, as I asked you guys, please keep it as the first in, first out for the queuing rule. All the queues, make sure they are a queue, not a conveyor. And just for the sake of similarity of our results, keep the length as 20. Okay. And for entities, we have 3: empty box, monitor, full box. And for arrival, we have monitors that go to the monitor queue, an empty box that goes to the box queue. Every one of them comes to the system 1 at a time from the start of the simulation for as long as we run the simulation, and the inter-arrival time of both entities is 15 minutes, exponentially distributed. Okay, so far, simple, nothing tricky or anything complicated at all. Okay, let's do the processes together. Okay. Let's say, okay, monitors come to the system. They are already at monitor queue. And where do they go from there?
Packing table.
They go to the packing table. Then empty boxes also come to the system. They are already at box queue. That's where they have arrived. We specified that in the arrival. And empty boxes, where do they go from box queue?
Packing table.
They go to the packing table as well. Okay. Now, in the packing table is where the permanent attachment is supposed to happen. We are going to put one monitor inside one box. That's where two separate entities come together. They get processed in one location. That's the classic definition of permanent attachment. And they go through the rest of the process together. So it's a definition of permanent attachment. Okay. So we want to specify attachment overall, permanent or temporary, it doesn't matter. We always define one entity as the base entity. What do I mean by base entity? That's the entity that starts the whole attachment operation, attachment comment. Okay. And base entity can be any one of the entities. It doesn't matter. You just pick one entity, one of the two that come together as your base entity. Let's assume I consider empty box to be my base entity. And as I said, base entity is the one that stores the whole command and code for the permanent attachment. So empty box, which is already at packing table, is the base entity that I picked among these two. And the one that is going to start the whole lines of code or command for the permanent batching. I'm going to write down the code in the operation window here for the empty box that is at packing table. That's my line 3. The command for permanent attachment is join. Join on. What is the entity that this empty box is going to join? Monitor. Okay. So join one monitor. That's the command for attachment. And we also we're going to put the time for this attachment as well. And obviously, if I want to put the processing time, I always have to put wait. And we showed in that picture, that's the processing time has normal distribution. Wait, what's the value? 5 and 1. Okay. So keep that in mind. And then what is the entity that is coming out? So I have to here mention the name of this new entity. When I join one empty box with one monitor, what is the entity that is coming out?
Full box.
It's the full box that is coming out. And full box is going to
The inspect queue.
inspect queue. Okay. So that's the line that takes care of the permanent attachment. So the command for permanent attachment is basically join. However, for this permanent attachment to go through, we still need to do one more thing. We decided on which one of these entities is the base entity that is going to initiate the whole join operation and so forth. However, we have to specify for the other entity as well that, okay, if you get to a location and there is one entity that asked or started the join operation, okay, you are the entity that has to join. So we have to tell the other entity that if another entity started the join operation, do the join. How to do that? We have to go to the line where the other entity goes to the packing table. That's where the join is going to happen. Find the line where the other entity gets to that packing table. And right here on the rule, if you click on the rule, when the window opens, you see here, if join requested, we have to check that. If join requested, check that one. And then here it's changed to join. Okay, so we have to tell the other entity on the same line where that entity gets to the packing table where the join is going to happen that, look, be ready. If another entity asks for the join, go through the join. And then the base entity is the one that starts the whole operation and takes care of the process. But when the base entity starts the join operation, the other entity knows already to join. So the join will happen in the model. If you forget to press or check if join requested, then you get error. Okay, so we are done with the join operation. The full box, the new entity is out. And then the rest is simple. Full box goes from inspect queue to inspector, and then full box goes from inspector to ship queue. And at inspector, the processing time is normal for 2. And then full box goes from ship queue to shipping. And lastly, from shipping to exit. And at shipping, the processing time is weight, uniformly distributed, average 5, half weight 1. Make sure to save, guys, as we go forward. Guys, I want you to pay attention that in location, I said consider the capacity of every other location as 1. Other than queues, everything else has capacity of 1. Even the packing table where 2 separate entities came together and we put one monitor inside the box, still we kept the capacity as 1. So that's just how permanent attachment has been coded in ProModel. You don't need to change the capacity of this location to 2 just because 2 separate entities come together. You can keep the capacity as 1. And that means we get 1 monitor, 1 empty box, and we process this together and then send the full box out. Okay, so keep that in mind. For batching, this was not the case. For permanent or temporary batching, we had to increase the capacity of the location to number of entities to be at least equal to the number of entities that come together in that location. But that's not the case for permanent attachment. You can keep the capacity as 1. Okay, pay attention to that. And I also here, if you are done, I want you guys to define a variable that counts how many, what is the working process number for the monitors in the system. Also count total number of full boxes that left the system. Define a variable that does that for me. So for the working process variable, if I want to look at how many monitors are in the system for working process for the monitors, obviously I'm going to increase it when monitors come to the system and they are at monitor queue, and I'm going to decrease them when?
After they ship.
After they ship the system, because still when they are in the system, although they are in the box, but still they are monitor. So like in the real world, if your boss asks you, give me an idea of the working process for the monitors, I mean, your box doesn't care about empty box and full boxes. A monitor in the system is a monitor, no matter if it is in a box or if it is not in a box. So I would say I'm going to reduce or decrease this variable working process when a full box leaves the system. That way, a monitor is not in the system anymore. It has been shipped out. And where is the best place to increase the variable that counts number of full boxes that have been shipped?
Last line as well.
In the last line as well. The name of the variable, monitor shipped. We are going to run this simulation 400 hours. So we added 2 variables for working process and monitor shipped. And then we ran the model for 100 hours. Did you guys get the numbers? Run it for 100 hours. And then here, when I look at some variable summary, can you tell me what column you are going to look at for working process? For variable summary, what is your working process?
Average value.
The average value. Okay. What is the other column that is informative for work in process?
Maximum.
Maximum value.
Maximum value. For monitorship, which column you're going to look at?
Maximum value.
Maximum value.
Maximum value. Because this variable is going to increase by 1 every time I ship. So the maximum value is basically our last value, which is the same as current value. But as I said, total changes, average time per change, and current value, those are the columns that we never want to look at. Always mean, max, and average have meaningful information. Does average value mean anything for the monitor shipped?
No.
Absolutely nothing. Very meaningless. For monitorship, maximum value is the one that is the most meaningful. For work in process, average is the one that is most meaningful. And then next, maximum. Okay.
Professor, for the working process, we would to increase the working process also in the box queue.
I ask for the working process of the monitor. That's
Okay.
the question.
Okay.
I only need to increase it for the box, for the monitor when the monitors come to the system. If you have a different question to look at working process from a different aspect, yeah, you can increase it wherever that justifies your question. But here I ask for working process of monitors, so I increase it only when monitors come to the system, and I decrease it when a monitor leaves the system.